A block weighing 200 newtons is pushed along the surface. If it takes 80 newtons to get the block moving and 40 newtons to keep the block moving at a constant velocity, give friction force, Fs max, mass, force of gravity, normal force, mu s, and mu k.
So, in this problem, we first determined which data we had. By reading the problem, we got that the weight was 200 newtons, Fs max was 80 newtons, and the force of friction was 40 newtons. We also know that the gravity on Earth is 9.81 meters per second squared, and that the normal force is also 200 newtons, which is equal to the weight, because weight is a measure of force of gravity pulling down an object.
First, by clearing the mass in the weight formula, which is weight equals mass times gravity. We got that mass equals weight over gravity, and since we know that weight is 200 newtons and gravity in Earth is 9.81 meters per squared second, by using the calculator we got that the mass was 20.38 kilograms.
But apart from that, we also needed to get mu k and mu s. To get mu k, we had to take a look at the force friction formula, which is Fk equals mu k times the normal force. To get mu k, we had to clear the equation, so we got that mu k equals force of friction over normal force. When we substituted the values, we got that mu k was equal to 0.2, just like in the image. And finally, to get mu s, we used the Fs max formula. This formula was Fs max equals mu s times normal force. By clearing mu s and substituting the values of Fx max and normal force, we got that mu s was equal to 0.4.
When using the emulator, we noticed that when we applied 362 newtons of force to the mystery object, it started to move. So we can assume that this is Fs max. Also, thanks to the information that the emulator gives, we see that the friction is equal to minus 241.08 newtons. And also the emulator gives the acceleration, that is 0.98 meters over square second. So with this information, we can get the mass of the object. If we divide the force by the acceleration, we get the mass, and that gives us a result of 369.38 kilograms. And the mass times the gravity on Earth, 9.81 meters over square second, gives us the force of gravity, or weight, and that is 3,623.69 newtons. And with this information, we can also get mu s and mu k. So in order to get mu s, we have to divide the Fs max, 362 newtons, between the force of gravity, or normal force, and that gives us a result of 0.09 mu s. And in order to get mu k, we have to divide the friction, or Fk, between the normal force, that is 3,623.69 newtons, and that gives us a result of 0.65 mu k. And with that, we have all the data thanks to the emulator and thanks also to the formulas.
So to conclude, we got that Fx max equals 80 newtons, Fk, which is friction force, equals 40 newtons, mass equals 20.38 kilograms, force of gravity and normal force equals 200 newtons, and mu s equals 0.4, and mu k equals 0.2. Thank you.